I was in that hotel at 6 o'clock when it rang. Now you want to keep me till 7 here to get the draw. So, if I can have the slides as well, so on the screen. Thank you. What I'm going to try to present today is where are we about the status of energy efficiency and mostly the status of innovation in the built environment. There are a lot of claims about potential, about the state of technology, about the market readiness of a lot of technology, and there is a lot of claims that have to be yet to be verified, and there is also a lot of technologies that have a huge potential that have yet to be exploited to meet some of the targets or the challenges that the built environment is facing today, not only in the country here, but also all over the world. I chose to capture my experiences both as Director General and now General Manager of the Research Council in Construction, but also as three-term chairman of the International Energy Agency. That is a collaborative agreement between 27 countries and holds a portfolio of $70 to $80 million a year investment in applied research application in the built environment. So I chose to just tell you a bit for those who don't know a lot about the National Research Council in construction. First of all, the National Research Council covers more than construction, aerospace, and so on. We're about 5,000 people across the country, and our job is to create business opportunity through innovation in different parts of the priority of the country, but mostly working with the industry and taking things to market as much as we can. In construction, we are very unique because this is the only place in the world that has two mandates doing R&D for the industry, but we are also custodial of the building regulation, both the National Building Code that gets adopted by the provinces and the territory. And as you know, about 2 years ago, or a year ago, we released the Modern National Energy Building Code right now that is being adopted by the different jurisdictions in the country. We also are custodial of the Canadian Centre for Material Construction, in other words, where we provide an opinion for the suitability of a given material in construction, be it insulation or other type of building materials for use in buildings. So this is how basically most of the industry come in and get their window or their door to the market. We're not your typical fundamental application. So this is our job is to work with the industry through collaborative project and get things to the markets. We are in the business of applied research. Just some keywords, getting a little bit deeper in the presentation. We are an outcome-based organization. In other words, we try to move strategic, do a lot of projects to move to strategic objectives that are of major significance. For example, in this case, try to, as much as possible, to get drastic reduction in energy in building as opposed to incremental. And in construction, our delivery program is on the building services and indoor environment, all the HVAC, lighting, acoustics, and indoor air quality, and so on, both from the environmental occupant satisfaction, but mostly also the engineering and the physics and all that kind of things. We do a lot of work on building envelope systems, walls, windows, and construction materials. We get things to market access and materials. We have probably the largest facilities in North America about fire research, and mostly we do a lot of work on bridges and also water and so on infrastructure. In terms of our relationship in the regulatory system, most of you know that we are custodial of the national, so we run the Modern National Building Code through the National Code Commission and all the standing and technical committees across the countries. With NRCan, we released the Model Energy Code for buildings, and we're about a year or two to release the Model Energy Code for houses that is right now being developed with the different committees. We do market access for materials, where the industry basically get an opinion or an evaluation about the suitability of a given material, roofing, shingles, windows, whatever you want to call it. And they get a number that allows them to have their product to be in the market. Mostly, we don't do this alone. This is building regulation is a provincial and territorial issue, but the code is a model national building code, and what it allows is the harmonization of the national building code, and in this case, the energy code, which is the business of this team. We've taken a lot of things to decision-making tools that are being used right now across the country. Probably the hotel I'm staying with right now can use the first software, which is called IBANA, which is Building Noise Against Aircraft, because it allows you basically to have different design and hear, not only look at the data, but hear different type of aircraft that you put into, and hear different scenario, whether you close the window, open the windows, and so on, and you can hear different type of, your design implication. The one on the bottom allows you to put in a 3D or in data different type of configuration of skylight, windows, you name it, or light pipe and so on, and predict both the performance of the fenestration system by itself, but also the energy implications. So you can, depending what you want, whether you are looking at the life cycle analysis or you're looking at the performance of the system itself. The one on the right, DaySim, we meant it to educate people about daylighting technologies, both the daylit control systems, whether it's electrical lighting for daylighting and controls and so on. The one is on the top is called iQuest. It's very popular because it's the only software in the world that allows you to have a database of the entire volatile organic compound of different materials. And then it has a we measured on the emission facilities, the VOCs of different materials, and we also have a software embedded that allows you to predict the indoor air quality within a given room under different ventilation system, and also have energy implication if you want to. But if you're only looking for air change per hour only and not looking at VOCs, then you're not getting one of the biggest problem in buildings, which is a sick building syndrome. Some of the software allows you to look at the entire office buildings when you have dealing with open plan offices. We call it COPE. We spent 4 years with the 12 partners from the private and the public sector who are our partners, and funded 4 years to develop what we call a software that allows you to design, predict, and evaluate open plan offices, both from the energy efficiency module, occupant satisfaction for indoor air quality, ventilation, lighting, and acoustics, and also has a lot of case study that we've done through more than 800 workstation, whether you want to design the partition, the height of it, and the balance between acoustics and so on, and then you can get your lead or other rating. These are some of the software. I'm not going to go on about this in this presentation, but I wanted only to give you a snapshot of what we do for a business. We do a lot of commercialization as well for our patent that we do with the industry. The other part of my presentation is my experience as a chairman for 11 years of the International Energy Agency. So what it is a collaborative agreement between 27 countries. We do manage major project. Each of them is a 4-year project with 60 or 70 people dealing with the major strategic things. So as a chairman, we in our business is the R&D project. We do work on dissemination, getting the word out, and mostly we look at the forecasting 4 years ahead or 20 years ahead, which we call the Future Building Forum. Management structure, this is really a boring presentation, but just give you an idea about how it is structured. There is an office that disseminates and has a very ambitious website. You can find a lot of things there. There is 2 windows, one that runs basically the entire place, the engine, which is where the project management is. And then on the left side, the deployment engines, where we get the word out to the industry. So far, 46 major projects. When I say major, I mean each of them is about 40 million up. Downloads of our our technologies reach 2 to 3 million now a year, and we have on the books about 13 major projects, and I'm going to give you a snapshot what they are. Anyway, this is just to give you an idea where I'm coming from about the statement or the example I'm going to choose. But I want to reconcile, for those who are not in the end use of buildings, where are we today about buildings and built environment. It's a huge consumer of energy, as you know. Depending on the countries, you're looking at 30 to 40% of the energy use. There is not a single country in the OECD that is not making it a major priorities. And because of the economy becoming an issue, so the association between economy and disposable income for people and then the utility rate, it is much higher level. What made it more important is also the bullet number 2, which is the resulting GHG impact. It is also between 30 to 40% responsible for emitting of the GHG. So it is, whether at the policy level or at the industry level, it is a big topic, and it's a big major challenge for today's industry. In terms of solid waste, the minimum that you can get, depending on the data all over the world, is 25%. Many places are reaching 40 to 45% of the solid waste. And what the most drastic one is consumption. When we talk about footprint, depending on the sector, in the built environment, and I'm counting only construction for bridges, roads, and so on, it consumes about 50% plus in terms of primary resources. And that is the one that we need to hold when it comes to a footprint implication. Now, that is looking at the built environment, scary. But the problem is its fragmentation. Compared to all the sectors that we know of, it's one of the most resistant, and I'm going to be crucified for the word I just said, to innovation and technology, because it's very fragmented. My next slide shows that, and this is a simplification only, that the value chain is very, very long, and mostly it is an SME-based sector. And that is important, because when you try to make a change, utilities don't have an intellectual property mandate. They are in the business of saving energy, and that is very, very important. So who is going to do, when we develop a technology, it has to go somewhere, somebody who is going to make an impact. So the deployment path has to take into account that we're dealing with a very, very long value chain on the horizontal side, and this is a simplification. It goes from the building, production and material and transportation, that kind of things. And then you have the manufacturing. So you've got somebody who's trying to make a wall out of an insulation, a coating, and so on and so on. And each of them has its own specs. So then you're not dealing with the specs and the performance of the system itself, because the industry is dealing with the specs of every one of them. Then you're dealing with another value chain that deals with the assembly and the manufacturing and so on. Then you have the constructions on site, and then you have the entire life, which is what we call O&M, operation and maintenance. And then you've got another industry dealing with demolition or risk and so on. Vertically, there are major players in the decision making. On the top, you're dealing with the major one, which is the regulation, the design, the commissioning, and so on. And then you have regulation and so on, and then you have the whole industry that try to educate, and this forum, I hope, is one of the venues as well. I saw a lot of workshops. On the bottom, you have the transportation of the goods and so on. But each of these units, it's a huge value chain. It makes it very difficult. So the fragmentation of the sector and the fact that it's SME-based, in Canada, it's 90% of 10 to 15 member company or less. So you have companies that are mostly very, very small. However, now the large companies in the ICT sector now, and also in the material science, is looking at this big hanging fruit called energy management. And they want to make the same impact they have made in other sectors, because they look at that the energy management or the energy efficiency target or the green one can use a lot of the ICT and the material implication and make a major drastic impact on the energy efficiency as well as the green aspect of buildings. So what are the challenges today? I mean, we can go into a nitty-gritty thing, but I chose only to summarize at the high level. There is no country that I know of in the OECDs or in the Western world, and also all over the world actually, that doesn't have the challenge to try to reduce the climate change impacts of the mitigation technologies. So mitigation is one of them. The other aspect is how do we adapt to today's environmental load of climate change. Not many countries in the world have updated their weather data to recognize the new weather changes have taken place. So this is a major one, and there is a lot of claims there. The industry has changed to position itself as part of the solution for the future, for green and so on. And it's moving forward, but it's still a major challenge to have a one-stop shop of where people can get reliable information and at the end of the day use it reliably. The other part is we saw a lot of emergence of the industry, and a lot of jurisdictions have adopted rating tools. There are many rating tools that predict or give you points and so on about a lot of your design, about whether it's environmentally suitable or for your indoor environment and so on. It used to be only energy. Then it moved very quickly to the environmental impact. And now, just over 5 or 6 years, you've got so many rating tools in North America, the LEED and Green Globe and so on. In Japan, you've got CASB, Korean Green Building Council. Europe, some part of Europe has a performance, high quality environment, but not so much Europe, because Europe has chosen to have what we call the Energy Building Directive for buildings, which is their energy regulation. In terms of energy, if you go in terms of companies that are the building owners or the federal or provincial or territorial or state or whatever you want to call it, countries, they are not looking for 10% and so on. Now we are talking about 50, 60%. So the bar is much higher, and the environmental is like that. And so far, for example, if you go to US DOE and get the industry or the universities or whoever is trying to look for funding for compact fluorescent or fluorescent in general, the chances that you're going to get funding is very small, because right now LED is the future. So this is what the industry is facing. At the same time, the policies are taking place. And there are very, very favorable policies for innovation, for making business and growing in this area, because the policies are favoring innovation. There are incentives for both the homeowners and industry commercial owners, as well as for innovation for the private sector all over the world. Part of the stimulus package in many countries, but also part of the competitiveness taking place. But it's not about only radical energy. Right now, there is another buzzword coming, which a lot of people don't know exactly what it means: clean energy. The word definition of clean energy is different from a country to the other one, but mostly a lot of people talk about energy that basically either renewable or reduces at 90% or move to a zero energy. So this is a very high bar. The problem is, how do you get there? And how do you get there in a manner that is reliable and also in a cost-effective manner? These are two major things. The problem, buildings are not only about saving energy. They're not designed to save energy. They are designed for other aspects as well. But the bar is also higher for the client expectation. Indoor air quality is a big deal right now. So you can't just make the building so tight to the point where ventilation rates are not acceptable for indoor air quality. Then we go into the problem of the 80s and the 70s, where we had all this investment and so on, and then at the end of the day, we are to the same point that we were 30 years ago about the same literature review that we are today. So a comprehensive approach is very important, not to neglect that health and safety is a very big issue, and the bar is much higher, especially with the security aspect as well. The comment on predictability of cost is not new to all of you. I mean, it's very hard, it's very rare that you say people that met construction things on budget, and you've got it exactly the same way. So somebody in a lot of investment is trying to make that product, a building, just like a car. And the rating tools are moving toward that one. The problem is you have to have reliable tools that says, that the rating that you get is exactly the performance that you have. And that is one of the major problems. So I'm going to make a comment here. We know a lot about the energy efficiency of appliances. But we don't know a lot about real energy efficiency on-site, measured and verified in real buildings. And that is where the building owners are sitting. They want to make the investment. But you and I in the value chain have to make sure that when we provide a life cycle assessment, if it's a 5-year ROI, then it's a 5-year ROI. But there are emerging technologies that are really right now moving forward, and there is a huge investment with a lot of companies that are not traditionally called constructions. I summarized most of them in this slide. Of course, we can go into the nitty-gritty ones, but I chose to give you a snapshot of what are we hearing from different roadmaps in the world or Canada and so on. The first one is that material science has done wonderful things in the nanotechnology and so on to so many things, let alone our phones and so on, and so many things, especially in the medical sector and also, but not so much in construction. You can't talk about moving to the net zero energy building or close to 60% without dealing with the building envelope and the impact that material science, especially the dependence on oil-based product. The second one is considered by many roadmap and by many industry association as the biggest investment, the least risky, and also especially when it comes to building retrofit. Tomorrow's buildings, most of them are already here. So what do we do about the energy efficiency of today's buildings? So ICT, information technology, and or communication technology, the whole business of automation, sensors, and so on is already here. It's not going to back away. It's going to keep going, making a major impact. And it is considered as the one that is going to make a huge, it's already making a huge channel. The advantage is reliability of the interaction of the system. What is lacking there is that we don't know a lot about sensors. We know a lot about occupancy sensors. We know about the thermostat that measures only temperature, but we don't have indoor air quality-based sensor that trigger ventilation rate. But it's coming there. But you could see right now a lot of demos in trade shows and so on where it is going to be touchpad too. In other words, we don't need so many building operators to worry, one person worrying about 15-story or 50-story buildings, about the whole aspect of building services, let alone emergency services. Solid state lighting, what we guys call, or we call LED, is already here. It's just a matter of time, but it's not already in indoor lighting. There is a lot of problems with its acceptance and dealing with the color rendering and so on. But a lot of, in fact, a lot of transportation system, freeways, stop signs, and so on, have already LEDs right now. So the entire reflected ceiling and the HVAC design is about to change, but we need to make sure that it is properly integrated to the building and doesn't go against one of the biggest innovation barriers, which is you and I as a behavioral pattern in the buildings. Alternate energy sources is what basically most of those countries, including ourselves, are pursuing. The integration of biomass, solar, which is there and not there as well, wind energy, and also hydrogen, which have yet to penetrate the same way that it has been received its promises in the building sector. Now, in terms of policies and regulation, this is a very well-known slide. We see a lot of convergence of companies now. They said, okay, I have an insulation material, but that's for now, it's important, but the consumer, I have to deal with the rating of the wall, of the window, and so on. For the HVAC and lighting stuff, we're looking at the convergence where the companies are trying to look at a system as opposed to a product. On the side of innovation, a lot of companies as well, people like us and so on, are partnering with others to create what we call integrated or multidisciplinary research. The emergence of regulation as well as rating. Europe right now has the 24 member states, I think there are 24 now, have all of them their energy code for building as part of the Energy Performance Directive for buildings. And they have different versions as we speak. In fact, they also have a certification process for boilers and so on, and it has created an industry and jobs with real data that I have seen and also witness presentation about the industry that does verification, the audit, gives you the labeling and so on, which is a new way of seeing win-win both from regulation, not as a bad thing, but it's a smarter regulation because it's performance-based. The Model Energy Code for buildings as well in Canada is here, and the United States is trying, even though it's not being pushed so much in the States, but a lot of people are adopting regulation not as a regulatory mandated, but as almost like a standard, like the ASHRAE one. And then you've got the whole industry adopting LEED, which raises the bar, LEED or Green Globes and so on, which raises the bar. And then we've had our series of good practices in program like the R2000 houses for CMHC and so on, and NRCan, and the Housing Equilibrium, US Building America, which is basically a program applied for energy performance of houses, and so on. Now, what we decided to do is that there is sufficient rationale for really high performance to the point where the utility rates, the utility doesn't become a liability, it becomes a revenue for the owners. But somebody, or we have to be also fair, that they need some validation that the technology works, that the system works. Otherwise, they are the one who are going to take one of the biggest risks. So the building owners, basically today, they spend about $22 billion in Canada on energy for commercial buildings, by the way. This is ICI, institutional, commercial, and so on. In the United States, it's estimated around $200 billion a year. And it's expected to double in 2020 when you do the calculation between how the utility rates are going, the market, as well as the cost. So when you put them in a meeting like this and you ask, it's not acceptable to them to have 8 or 7 years payback. That's just too much. So when we speak about something and we are trying to make an impact, we have to recognize that we have to basically develop absolutely reliable, life cycle-based technologies or prediction models. So they are hungry, and they are very, very aggressive and early adopter as opposed to risk-averse building owners, be it public or private sector, that is looking for validated retrofit technologies. And this is also what the utilities does. They are trying to promote. They are not in the fundamental one. They say that we know enough to do something, but they are looking for the one that are close to market or that are in the market, but there is some doubts about them. That's because the ICI, too, has a 13% by them GHG reduction, and there is very favorable policy to reduce it. Now, so the industry sees the opportunity. You look at the major, I sit down on the building automation industry as on the board of directors. On half of the board is Microsoft and Bell and so on. That's because it's becoming a major opportunity. And the automation, the ICT aspect, especially the energy management, and also the next generation of building envelope, which is not a building automation issue. So they see the opportunity to stabilize the energy supply, but mostly it is estimated in our country as a $40 billion a year addressable market in North America as opposed to Canada only. And that is basically a reality. There's a huge, huge competition right now taking place to address the energy efficiency of large metropolitan areas. New York, and there is also the Clinton Foundation for the major cities and so on. So people are looking at the community as well as building, but a lot of them are also looking at the energy management and the connectivity with the utilities. So we see an opportunity, and we're not the only one, that we need to work together in the value chain on specific things that will provide market access and validate the technology for commercial buildings on high scale and real buildings, as opposed to only at the product level. And that value proposition becomes an owner proposition, that in 7 or 8 years, that becomes a revenue as opposed to a liability, because there is sufficient technologies. The problem is the whole value chain and also moving to validation as opposed to and reliable prediction as opposed to continue on the same trend. So when we talk about the way we look at this is we look at the building has many systems: fire, security, and lighting, and HVAC, and voice, and so on. If we don't integrate them, it doesn't work, because just for practical reason and marketing reason, the building users are not going to go along. So the entire industry is trying to converge that onto one system. They are converging among themselves as partners, or they are just taking it on their own and validate it. And mostly it's also touchpad. Then you have another one, so there is an integration gap. And the other one is that if you want to move the energy forward, you really have to look at getting a smart skin facades. The one that are embedded with photovoltaic for windows, as well as the high performance insulation that will take you to 50 to 60%, or has thermal resistance from 6 to 1. Storage is the same thing. So what we're trying to do is look at the whole thing and have valued product that goes out in each value chain, going from the energy positive component and mostly to the intelligent application. So there is an application on the consumption management, and the other one at the response demand, because we have to deal with the peak and deal with this saturation of our utility grids. And there is another one which is critical, is the storage management. If you store energy, if you basically capture energy, you have to store it and use it when it's appropriate, because right now, in 5 or 6 years, there is no question that we're going to buy energy on demand, because the technology is already there. So it's a two-way communication. This is where the utility meets you, by the way. On the IEA, the 27 countries, when you reconcile all their vision and their policies, we couldn't have a better vision or more. The only one that we found common is that we needed to move the sector to adopt near primary energy use. When you have a 50% primary energy consumption, you don't have a choice. So we don't accept any project, major ones, that doesn't basically give us a huge potential when we evaluate it, that it's going to go and give us a chance for 50% energy reduction. And the same thing for reliable life cycle performance. They have to use a very good tools to give us some reliability that we are going to move really to that way. And you cannot talk about energy efficiency if you don't use robust life cycle tools. Now, the way we do this at the IEA is that it's either you affect the decision making, which is regulation, or design and so on, or you affect the hardware, the next generation of HVAC, or LED and lighting, or insulation product. But mostly, you have to put it in practice. You can't just put the specs without really know how it works in the real buildings, because it's a very heavily regulated industry and moves only to faster if you prove it in the real buildings and that requires partnership between the value chain and the building owners. So what we've done, some sample of the project. There was a big hype 4 or 5 years ago about hydrogen applications. So what we've done, we put 15 countries, because it's a huge investment, and we took a lot of engines, we called hydrogen engines or fuel cell engines, that were very close to the market or ready to the market. And we basically measured their performance in generating power for cooling and heating. And then we developed models right now that are embedded in all the energy software that I use widely in the world. So the one on the right is our Canadian Center for Housing Technology in campus next to my office, where we tested the fuel cell, some engines. And on the one on the bottom, that's in Penn State in the US. So what we did, we basically measured their performance, their technological barriers, because some of them goes to very high temperature and it becomes a fire hazard at that time. And then we looked at the cogen performance in the environmental one. So these are some of the sites in Germany and Canada where we tested the potential of hydrogen in generating cooling and heating power. And then we developed reliably those specs, and we gave them to industry, an association like ASHRAE and so on, and they were adopted for different, because if you don't have the specs for the Stirling engine and God knows whatever, then how can you possibly predict the energy performance of those systems and so on? And then for the people who are in modeling and prediction, we put them into popular, widely used software, energy software, depending what the country used. So Energy Plus in the US and EASE and some of the NRCan Hot 3000, and they were embedded there. The other one, high-performance insulation, is used widely in different sectors and used to cover the pipes and so on. Their thermal resistance is 8-to-1, as like this chart shows, compared to conventional insulation. But it's not widely used here. The reason is you have to put it into a system and safely move it to application and demonstrate that it's safe to use and also get its proper spec. So you have to put it into a system. And so our job within so many countries was to develop their potential and look at their really suitability for fire hazard and so on. So we put that, and right now it's widely used in many, many countries. And there is no way in the world that we're going to move to those very aggressive energy target with energy management alone. You have to deal with the thermal resistance and also other moisture problems with the envelope. Building services is the bread and butter of the IEA. That's because they look at this as the highest potential for energy savings and the least riskiest and the most reliable. And we looked at the real performance of LED in lighting and overcoming the barriers, and I don't want to go into the real data in this presentation. The heat pump, reversible air conditioning, mostly commissioning, which is a crucial one. How do you do proper commissioning, a quick commissioning, and how can you have fault detection that basically remind you of commissioning, both for lighting as well as HVAC. We have done so many buildings monitoring, and you could see that just by some sensor calibration that doesn't get done, that there is 50 or 60% of energy saving that gets forfeited, especially on the HVAC and lighting systems. The one that I want to spend a few minutes here is when you do in the business of retrofit, we look at when it comes to building envelope, we have to recognize that productivity is a major issue as well. So we did a very aggressive annex that gets away from the forecasting and so on and moves straight to application. We thought that there was enough knowledge to take a risk and pour collaborative effort and get partnership with the major aggressive building owners and go into 5 buildings and look at the potential of them of retrofitting using prefab, directly prefab, with high performance insulation. So basically we took buildings And we measured before that there is a high potential, and worked with building owners in Switzerland, Austria, and so many countries there. And the slide that you see here is the whole building envelope was retrofitted like in 1 or 2 weeks for 4-story. And you're going to see the slide on the left is before, and the slide on the right, it's after. So you do building energy retrofit, but you also offer the value proposition to the building owners to reduce construction costs and also time, and also accuracy, and improve accuracy as well. So this is some of the thing that is taking place when people are looking at the energy for retrofit, not blindsided that there is another value proposition that you can make. And of course, the energy management came separately. The thing that these countries, ourselves included, are investing a lot of effort is we really need to provide as-built performance is as close as possible to the as-design. When you measure both, there is a huge disparities, and it discredits some of the good work that a lot of people do, because we need to invest and validate our technology and say, oh, this is how it works in the real site, and we go back and improvement. So we decided that we need to go and do a really full scale. How can we develop methodology that provides reliable prediction of as-built performance? If you want to give a rating to a building owner about, or a design company or utility-based private sector that they have predicting and they gave a rating, you need to have that rating basically translated into real performance. The second one is, when you address CO2, we don't have a CO2-based tools. So we use kilowatt hours as a unit. And there is no question that CO2 is going to be a design, or something like that is going to be a design unit. But we don't use, I mean, the CO2 and the GHG and so on are not today a design unit. A design unit is temperature, Celsius and so on, kilowatt hour, and rate, air change per hour, heat transfer and so on, or coefficient of performance. But we don't have an environmentally based or CO2 based measurement yet. So we're taking a crack, how can we get there? So that we have those designed before, but as long as we don't have it, then we shouldn't really probably speak that much about it, because if you don't design it for it, how can you measure it? And it's the same thing for the renovation business. At the National Research Council, we took a crack in the last 9 to 10 years onto 3 topics. One on the energy efficiency, and the other one is trying to integrate renewable, but mostly measure that performance. And of course, support the government into developing the model energy code for buildings, which we just released, the 2011-16 code. And right now we are working on developing the model energy code for houses with NRC and the Code Commission, and also all the standing and technical committees. And the way we've done a lot of projects on both on the lab, large-scale facilities, and also on the real site, measuring, predicting, and develop technologies on the automation sensor networks. Right now we have a major investment with the private sector, looking at integrating and overcoming the market barriers of LED in real sites. High-performance insulation is also at the material level, both at the system level. And we did a lot of work on demand-responsive building, not only from the HVAC, but how do you reduce power without people noticing, so that you can deal with peak shavings. The one I wanted to talk about is some of the technologies that we have just finished, where your badge is also used as a connection to the energy management system. Energy management, you cannot really have the occupancy by itself and have the temperature sensor by itself and so on. All of these are going to go to the energy management systems, and it has to be done intelligently there as well with a control unit and so on. So what we decided to do is that we basically look at the wireless technology being exploited, combining both the preferences of the occupant that get saved, for whatever office or workstation, combined that with the occupancy sensors, with also the design of the unit and so on, and integrate that into one. And just in 6 months measurement, we have facilities that can mimic office building with real occupancies. The savings and with the real occupancy was about 30% and so on. And we have a video about that as well, and you can see on the right as well all the controls that were done. The one that we decided to know exactly how much you can go in the demand responsive building, both for the HVAC and lighting, and reduce the temperature or lighting, whatever, without any complaints. And we've done that on site with a lot of partners from Public Works, NRC, APRI from California, CRI, Lutron, and so on. And we basically demonstrated that you can go and do a lot of peak shavings, applying advanced energy responsive technologies with zero complaints whatsoever. And you can see the dip on the right slide. So my presentation today is not about to tell you what to do and so on, but I'm hoping that it provided a snapshot. Where are we in the built environment, the challenges, but there is a path there, and I'm ready for questions. Thank you very much for having me.